Hello everyone. In this video we're going to be solving a nice exponential equation. We have 49 to the power x minus 42 to the power x equals 36 to the power x. At this point you can try to guess the solution, see if you can get it just by guessing. But I'm going to show you how we can solve these kinds of problems. So whenever you get a problem like this, we kind of need to check something. 49 is a perfect square, 36 is a perfect square. If you square root those numbers, you get 7 and 6. If you multiply them, you get 42. There we go. It passes the criteria. So here's what we're going to do. We're going to go ahead and divide everything by the expression with the largest base, which is 49 to the power x. So let's go ahead and divide everything by that. Now this is going to give us something nice. You'll see in a little bit what that looks like. 49 cancels out. We get 1. And we can write these as 42 divided by 49 to the power x. And this one is 36 over 49 to the power x. Great. We're going to simplify this because 42 and 49 have a common factor. Notice that they're both divisible by 7. So we can go ahead and divide by 7. And this gives us 6 over 7 to the power x. And that kind of goes well with 36 over 49 because you see it, 6 over 7 squared equals 36 over 49. So if I use substitution here, this is going to be nice. I'm going to go ahead and call this something. How about t? Let's call this t, and this will become t squared because of this reason, okay? So we get 1 minus t equals t squared, and then let's put everything on the same side. T squared plus t minus 1 equals 0. And guess what? This problem, or this equation, has an interesting flavor. You'll see in a little bit. Let me go ahead and find the t values. Negative b plus minus the square root of b squared, 1 plus 4, which is 5, divided by 2. Yes, if you said golden ratio, you got it. We can go ahead and split up these values as t sub 1 and t sub 2. Let's start with negative 1 plus root 5 over 2. And let t2 be negative 1 minus root 5 over 2. Here's the problem. T is 6 over 7 to the power x. So let's go ahead and write that down here. And 6 over 7 to the power x cannot be negative if x is a real number. So we can talk about two different things. One, if we're looking for real solutions, and then 2, if we're not looking for, or we're looking for all solutions. So let's go ahead and set it up, like set it equal to 6 over 7 to the x, and you're going to realize the second t value is negative. So this is supposed to be less than 0. But with real x values, that's not possible. So let's go ahead and focus on the real solution first. If I get 6 over 7 to the power x, and I'm going to write this number as root 5 minus 1 over 2. Just looks better. And then we can go ahead and natural log both sides and find the x value. Easiest way to bring down the x. You can also use the definition of logs. Doesn't matter, no big deal. But just ln this and ln that, and you'll be good to go. This x, you can bring it down. X times ln 6 over 7 equals ln root 5 minus 1 over 2. And then finally, by division, we get x equals ln root 5 minus 1 over 2, the golden ratio, divided by ln 6 over 7. Of course, you can write this as ln 6 minus ln 7, but that's not a huge improvement. Okay? So that's the real x value. What about the complex x value? Let's go ahead and see what that looks like. So 6 over 7 to the power x equals negative 1 minus root 5 over 2, or you can write it as negative root 5 minus 1 over 2. Okay? Now, when you take the log of both sides, obviously, or the natural log, you're going to have to ln a negative number. But you can't just ln a negative number because for the real values, it's not defined. But we're talking about complex numbers here. So what does that look like? So here's what we're going to do. We're going to write this as a complex number. How do you do that? Using polar form, using Euler's formula. So think about this number. It's a negative value, so it's some type of negative number here, which has a real part but no imaginary part, right? So in other words, actually, that's not true. I mean this one. Okay, so all real numbers are going to appear on the horizontal axis, which is the real one, and this is the imaginary one. Okay, so that's not right. So our number is going to be here, and the angle that it makes is going to be pi radians. Make sense? So how do you write a number in polar form? Z can be written as r times e to the I theta. Theta is the angle, we know that, and r is the modulus. Since this number is negative, its modulus is going to be its absolute value, which is the opposite, obviously. So here's what we're going to do. We're going to write this as, let's see, r is going to be the absolute value of this number times e to the power I times pi. Okay? That's going to be I pi. And now what we're going to do is now ln both sides. When you ln both sides, it's going to be kind of interesting. But one thing to keep in mind is pi is not the only angle for which this is true, because if you just add to pi multiples of 2 pi, then this equation will still be satisfied because they'll have the same cosine and sine. It's just going to give us a rotation of 2 pi, which is going to bring us to the exact same point. Now log both sides, x ln 6/7 equals, when you ln this, it's just going to be the ln of a positive number, so it's going to be a real value, plus the complex or imaginary part is going to come from here, and that's going to be I times pi plus 2 pi n. Since we're looking for the x value, we can go ahead and write this as ln root 5 plus 1/2 plus I times pi plus 2 pi n, and again, you can factor out a pi if you want, divided by ln 6/7. So this is going to be a complex number, and that's going to be the complex solution. And this brings us to the end of the video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.